Okay, I want you to just close your eyes for a second.
Mm
Imagine you're standing on a surface. It's solid rock,
hmm. Mm hmm.
but the air around you, well, it's not really air.
Not at all. It's a supercritical fluid, basically. It's thick.
Yeah, and the pressure, I mean, the pressure pushing on you, on your chest, your eyes,
Yeah.
it's 90 times what you're feeling right now.
That's the equivalent of being a kilometer deep in the ocean, the kind of pressure that crushes submarines.
But you're not wet. You're bone dry.
Yeah.
And the temperature is 465 degrees Celsius.
Yeah, to put that in perspective for you, lead melts at about 327 degrees.
So you'd be a puddle.
You would be a puddle.
Zinc?
Zinc melts at 419, so if you were a zinc robot, you're also a puddle. You're standing inside a self-cleaning oven, but during the cleaning cycle.
While being crushed into a diamond.
At the same time, it's just the worst of all worlds.
This is the surface of Venus. It is, by pretty much all accounts, a complete hellscape.
The most hostile planetary environment in the entire solar system. Hands down.
And yet, for a period of about 20 years, the Soviet Union looked at this absolute nightmare world and decided, you know what? We're going to land there.
And not just land, they wanted to take pictures. They wanted to record audio, drill into the rocks.
It's insane ambition.
It is. We are talking about the Venera program. Venera, of course, being the Russian word for Venus. And from 1961 all the way to 1984, the Soviets launched this relentless campaign to conquer the planet.
I think campaign is exactly the right word.
Yeah.
Because when you look at the source material we have here, the mission logs, the declassified reports, this wasn't just science for science's sake.
No.
This was a war against physics, against chemistry, and as we'll see, a war against Murphy's Law.
It really was. And for a very long time, Venus was winning.
That's what we are unpacking today. We've got a huge stack of material here, and we're going to look at how humanity, against all odds, managed to touch the surface of a planet that seems designed to destroy everything that comes near it.
But we're not just looking at the wins. The successes are amazing, but the failures, the spectacular, hull-crushing failures, they tell just as much of the story.
And the sheer absurdity of trying to do precision engineering in hell.
Right. So the mission of this deep dive is to really understand the how. How do you build a machine that survives where lead melts? And maybe the bigger question is why? Why did they keep launching them when they just kept dying?
Before we get into the nuts and bolts, literally, I think we need to establish the stakes. Because in the West, I feel like we often gloss over the Venera program.
We do.
We talk about Apollo, we talk about the Mars rovers. But Venera, it racked up some incredibly serious accolades.
It's a staggering list of firsts. I mean, the Venera program is responsible for the first human-made device to even enter another planet's atmosphere. That was Venera 3.
Then you have the first soft landing on another planet.
That was Venera 7, a huge one.
The first images ever returned from the surface of another world.
Venera 9. I mean, think about that. The first time humanity saw the ground on another planet.
And maybe my favorite, the first sound recording on another planet.
Venera 13. Yeah, these weren't just publicity stunts. They were foundational moments in planetary science.
But the road to getting those records, as you said, was paved with a lot of silence.
And a lot of very, very expensive scrap metal.
Okay, so let's rewind to the beginning, Section 1. The era of secrets and failures. We're back in 1961. Yuri Gagarin hasn't even flown yet. The space race is just getting started.
Right, and it's important to understand the mindset here. The Soviet Union wanted to prove their dominance in space. Mars is, the obvious target in popular imagination.
The red planet.
Exactly. But Venus is actually closer. It's our nearest planetary neighbor. And in terms of the energy you need to get there, it's actually slightly downhill from Earth relative to the sun.
Downhill makes it sound so easy.
It is absolutely not easy. When you're falling toward the sun to get to Venus, your spacecraft speeds up a lot.
So you arrive way too fast.
Incredibly fast. So while it takes less rocket fuel to get there, you have to shed all that velocity. Otherwise, you'll just whip right past it. It's a huge braking problem.
So February 1961, they launched Venera 1. What was the plan?
The plan was just a flyby. They weren't even trying to land yet. They just wanted to get close, take some measurements, and basically plant a symbolic Soviet flag in Venus's orbit.
And it launched. Okay.
Launched successfully, left Earth orbit, headed out into deep space. Everything looked perfect.
Until it didn't.
Right. 7 days into the mission, telemetry failed.
Okay, let's pause on that word. Telemetry. We hear it all the time in space movies. We've lost telemetry. What does that actually mean for an engineer in 1961?
Telemetry is the spacecraft's heartbeat. It's the constant stream of data that tells you, my battery voltage is this, my internal temperature is that, I'm pointed in this direction.
It's the health report.
It's everything. Without telemetry, you have no idea if the ship is alive or dead. You can maybe track it on radar as a tiny dot, but you can't talk to it. Can't talk to you. Venera 1's radio basically just died.
So it became a ghost ship.
Exactly. A silent, dead brick flying through space. It did pass Venus, missed it by about 100,000 kilometers, which is actually a pretty near miss in astronomical terms.
But it couldn't tell us anything.
Nothing. A complete scientific failure.
And then there's Venera 2.
Fast forward to 1965, it's almost the exact same story. It survived the launch, traveled for months, millions of miles, and then right before the flyby encounter, silence.
What happened that time?
The communication system overheated and just fried itself. Another ghost.
This has to be just soul-crushing for the teams on the ground. You spend years building these things. You get them all the way there, and they just go mute. And this brings us to a fascinating part of the Soviet space program, the secrecy. They weren't exactly putting out press releases saying, hey, everyone, we lost another one.
Oh, absolutely not. This is the whole concept of maskirovka, which is a doctrine of military deception. The Soviets had a strict policy. You never, ever admit failure if you can possibly hide it.
So if a probe failed to even leave Earth orbit,
You don't admit it was a Venus probe. You give it a generic cover name.
like Tizeli Sputnik.
Exactly. The very first attempt to go to Venus, even before Venera 1, failed to leave its Earth parking orbit. It was just stuck, circling the Earth.
So what did they tell people?
The official news agency, TASS, just announced the successful launch of Tizeli Sputnik.
Which means,
Heavy satellite.
I mean, that's technically true. It was a satellite and it was heavy.
It's the best kind of lie, right? It's technically accurate, but it completely hides the intent. They did not want the Americans to know they were trying for Venus and failing right out of the gate.
And this evolved into the Cosmos designation.
Yes! Cosmos became the great big wug they swept everything under.
I've seen this in the history books, yeah. There are thousands of Cosmos satellites.
And it's a catch-all. Spy satellites. Cosmos. Experimental weapons platforms. Cosmos. Failed Mars probes, failed Moon probes, and yes, failed Venus probes, all just given a Cosmos number.
So if you see a sequential Cosmos number, like Cosmos 96, it probably means this is something we aren't going to tell you about.
It's a huge red flag for historians, and Cosmos 96, that's a story that I just love because it connects this Soviet secrecy to some classic American folklore.
Oh, this is the Kecksburg
This
incident.
is the Kecksburg incident. So Cosmos 96 was launched in November 1965. It was a Venera-style lander, a proper one. But the final booster stage, the kick motor that was supposed to send it to Venus, it failed.
So it was stuck in Earth orbit again.
Right, and its orbit started to decay. It was going to fall back to Earth uncontrollably.
And where did it fall?
Well, on December 9th, 1965, a massive, brilliant fireball was seen streaking across the sky over Canada and the U.S. Midwest. Thousands of people saw it, and observers in Kecksburg, Pennsylvania, reported that something had crashed in the woods.
The famous Kecksburg UFO.
That's the one. The military immediately cordoned off the whole area. People claimed they saw an acorn-shaped or bell-shaped object, which, ironically, is roughly the shape of a Venera descent module.
And then the government just said, nothing to see here.
Exactly. Total stonewall.
So the entire time the UFO community is thinking it's aliens, and the U.S. military is probably scrambling to recover secret Soviet tech, the reality might just have been a failed Venus probe burning up.
The timing aligns perfectly with the predicted reentry of Cosmos 96. It's the most probable explanation. So you have this beautiful irony. The Soviets try to hide a failure with a generic name, and in doing so, they accidentally spark a 50-year American conspiracy theory about a crashed UFO.
That's absolutely fantastic. Okay, but let's move from things crashing on Earth to things crashing on Venus. Section 2, the atmospheric crush.
Right.
This is the period from about 1966 to 69, covering Venera 3 through 6. This is where they start actually hitting the planet.
Yeah, and Venera 3 is a milestone. It's the first human object to impact another planet. That was March 1st, 1966.
A huge moment.
A huge symbolic moment. But again, the communications failed before it even hit the atmosphere, so it was a ballistic impact. Just a bullet hitting a wall.
So it's a moral victory, but a scientific zero? No data came back.
Correct. But Venera 4 changed everything. It was launched in 1967, and this one was designed to release a descent capsule, a probe that would hang under a parachute and measure the atmosphere on the way down.
And did it work?
It worked. It actually sent back data from inside the Venusian atmosphere, and the data was just shocking.
What did it find?
It analyzed the gas composition, and it found that Venus was 90 to 95% carbon dioxide.
Why is that such a shock?
Because on Earth, CO2 is a trace gas. It's a tiny, tiny fraction of a percent. To find an atmosphere that is almost pure CO2 was mind-blowing.
And it immediately explained the heat?
It confirmed the theory of a runaway greenhouse effect. The planet was wrapped in a thick, heat-trapping blanket.
But there was a problem with Venera 4's data, right? A major discrepancy.
There was. The Soviets initially claimed it landed successfully. The telemetry just stopped, so they assumed, okay, it must have hit the ground. They even published drawings of it sitting on the surface.
But something else happened.
The American Mariner 5 probe flew by Venus just a day later, and it measured the atmosphere from space using a technique called radio occultation.
Which is?
You basically see how radio waves from the probe bend as they pass through the planet's atmosphere just before it goes behind the planet. The amount of bending tells you the density and pressure.
And the numbers didn't add up.
Not even close. When scientists from both sides compared the data, they realized something terrifying. The pressure where Venera 4 stopped transmitting, it wasn't the surface pressure. The probe's altimeter had probably given a false reading in the weird atmosphere.
So where was it when it died?
It was still 26 kilometers up in the air.
Wait, so it died in midair?
It was crushed.
Crushed.
Think about the engineering. The hull was built to withstand 25 atmospheres. That's 25 times Earth's sea level pressure. That is strong. That's a deep sea submersible.
But Venus isn't 25 atmospheres.
No. We now know the surface is over 90 atmospheres. So as Venera 4 descended on its parachute, the pressure gauge was just climbing 10, 15, 20, 25, and then boom, structural failure.
Can you describe what that kind of failure looks like? When we say crushed, what physically happens to a titanium sphere?
It's a violent implosion. But it's not just a clean crack. At those pressures, and combined with the intense heat, the metal undergoes what's called plastic deformation. It literally starts to buckle and flow like clay.
Oh, wow.
The sphere would have been squeezed into a crumpled, twisted ball of metal in milliseconds. Everything inside, all the delicate electronics, would just be pulverized into dust.
So they basically sent a submarine rated for the shallow end of the pool into the Mariana Trench.
That's a perfect analogy. And the worst part, they had already built Venera 5 and Venera 6. The hardware was sitting in the hangar in Moscow, built to the same flawed 25-atmosphere specification.
So what do? Do you just scrap the missions? You know the probes are going to be destroyed.
The Soviets, never. You adapt. They came up with what they called a jettison strategy. They stripped every single ounce of non-essential weight off the descent modules.
To make them stronger.
To make them smaller and lighter, and to let them fall faster. They used smaller parachutes so they could get deeper into the atmosphere before the inevitable crush happened.
That sounds incredibly desperate. Like, we know it's going to break. Let's just see how far down it gets before it does.
It was pragmatic. It was desperate, but it was pragmatic. And it sort of worked.
How so?
Venera 5 and 6 were launched in 1969. They transmitted data for over 50 minutes each as they fell. They got much deeper than Venera 4.
How deep?
Venera 5 made it down to about 26 kilometers in altitude. Venera 6 got all the way down to 11 kilometers.
So they're inching closer. 26,
Yeah.
Now 11.
They're mapping the death zone. But they both succumbed to the pressure. The batteries probably failed or exploded. The seals blew out. The hulls collapsed. But the data they sent back was invaluable. They were mapping the pressure curve, learning exactly how hostile this place was.
There's a really weird detail in our design notes here. It says that some of the early Venera probes carried sugar and were designed to float.
Yes. This shows you just how little we knew. As late as the mid-60s, there was a completely valid scientific theory that Venus might be covered in oceans.
Oceans of what? Water?
Maybe. Or maybe oceans of oil. Or even carbonated water. So the engineers actually included a block of sugar that would dissolve in liquid water to release the antenna. And the probe itself was designed to be buoyant, to float.
Imagine the irony. You painstakingly build a boat and you drop it into a blast furnace.
It perfectly highlights the radical shift in our understanding. In the span of about 5 years, Venus went from possible tropical paradise to absolute, unequivocal hell.
Which brings us perfectly to Section 3. The tank on the surface. The year is 1970. The engineers at the Lavochkin Bureau are done playing games. Enter Venera 7.
Venera 7 was a beast. They completely abandoned any attempt at scientific elegance. They just said, okay, the pressure is 90 atmospheres. We will build a hull that can take 180.
Just double it. Brute force engineering.
Pure brute force. Instead of a standard aluminum-magnesium alloy sphere, they forged a massive egg out of titanium. It was so incredibly heavy that they had to strip out almost all of the scientific instruments just to get the thing off the ground.
So what was left? It was basically a heavily armored thermometer.
That's pretty much what it was. A thermometer and a barometer tucked inside a cannonball. They launched it in August 1970. It arrived at Venus in December.
And the landing? I'm guessing it didn't go smoothly.
Nothing on Venus ever goes smoothly. During the descent, the parachute ripped. It seems to have failed or gotten tangled.
So it fell.
It plummeted. It hit the ground at about 17 meters per second. That's nearly 40 miles per hour.
Oh my God.
Imagine dropping a bank safe from the roof of a 4-story building. That's the kind of impact we're talking about.
And it survived that.
The hull survived. It was a tank, but it toppled over. It rolled onto its side when it hit the ground.
Which I assume caused another problem.
A major problem. The main antenna was designed to point straight up at Earth. Now it's priming sideways, maybe even partially into the Venusian dirt.
So, silence again, after all that.
For a moment, they thought so. The signal was incredibly weak, almost lost in the background static. But then the signal processing team, back on Earth, they started seeing a very faint, repeating pattern in the noise.
What was it?
It was the probe, stuck in one mode, just transmitting the temperature over and over. They used what was, for 1970, advanced computer processing to pull this whisper of a signal out of the noise. And there it was.
A voice from the surface.
For 23 minutes, for 23 agonizing minutes, Venera 7 sat on the surface of Venus, roasting at 475 degrees Celsius, being crushed by 90 atmospheres lying on its side. And it kept screaming its data back to Earth.
How did it tell us?
It gave us the first direct temperature and pressure measurements from the surface of another planet. It confirmed, absolutely, undeniably, that the surface is solid and it is hellishly hot. No oceans, no swamps, just hot rock.
23 minutes doesn't sound like a long time. But when you consider the environment, it's an absolute eternity.
It was the proof of concept. It was the moment they proved you could build a machine to survive hell, even if only for a little while.
And that paved the way for Venera 8 in 1972.
Right. Venera 8 was smarter. They learned from the parachute failure, and they fixed that. They also added a photometer.
A light sensor.
Exactly. This was crucial. They needed to know, is it pitch black down there? The clouds are so thick, some scientists thought the surface might be in total permanent darkness.
And if it's dark, there's no point in sending a camera later.
Exactly. So Venera 8 landed, and it survived for 50 minutes, almost an hour. And the photometer showed that, yes, there is light.
How much?
It's about as bright as a really overcast day in Moscow. Or, twilight, you could see.
Okay, so we have a solid surface, we know there's light, and we have a tank that can survive for about an hour.
No.
Now we want a picture.
Now we want a picture, which brings us to Section 4, the photographers and the curse of the lens cap. This is the golden era, from 1975 to 1978.
The lantern designs changed here too. The earlier ones were just these simple balls. These new ones, Venera 9 through 12, they look like proper sci-fi spaceships.
They are magnificent machines. They launched on the Proton rocket, which is a much heavier lifter. This allowed the landers to be huge, 5 tons. They have this giant metal sphere at the bottom for the electronics, surrounded by a donut-shaped crash absorber with a big aerobrake disc on top.
And they had to solve the heat problem for longer missions. How do you keep electronics working at 465 degrees Celsius?
You can't use a normal fan or radiator because the outside is hotter than the inside.
Right.
So they used what's called a thermal inertia system. Basically, they pre-cooled the entire interior of the probe to freezing temperatures before it hit the atmosphere.
Like putting it in a freezer.
Exactly. Then they surrounded the electronics with layers of insulation and special phase change materials, stuff that absorbs a huge amount of heat as it melts. It's like bringing a cooler full of ice to a bonfire. Eventually the ice melts and everything inside gets cooked. But it buys you an hour, maybe 2.
Okay, so Venera 9 lands, October 1975. The goal: get the first picture from the surface of another world.
It lands, the system works, and it starts transmitting an image, a black and white panorama.
What did we see? What was the first thing humanity saw on Venus?
Sharp, jagged rocks, which was a surprise. A lot of scientists expected the high pressure and constant wind to have eroded everything into sand like a desert on Earth.
But it wasn't like that.
No. It looked like a young tectonic landscape, broken slabs of bedrock, very little dust. It was stark and alien and terrifyingly beautiful.
But the image wasn't a full 360-degree view, was it?
It was not. And here, our main villain for the next few years enters the story: the lens cap.
The lens cap.
The camera had a protective quartz window, and over that was a metal cap to shield it during the fiery descent. Once on the surface, a pyrotechnic charge, basically a small explosive bolt, was supposed to fire and pop the cap off.
Okay, seems simple enough.
Venera 9 had two cameras, one on each side, for a full panorama. On one camera, the cap popped off perfectly. The other one didn't.
It got stuck.
It got stuck. The best guess is thermal expansion. The metal ring holding the cap probably expanded in the intense heat and just jammed the mechanism shut. So one camera saw the surface of Venus, the other camera saw the inside of its own lens cap.
50% success. Not great, not terrible, I guess. So what about Venera 10?
Same design, launched just a few days after Venera 9. It lands in a different spot, and same story. One cap pops off, the other one sticks. Again, it became very clear the design had a systemic flaw. But we did get another incredible photo from the working side. This time, the rocks were smoother, more rounded, like old lava flows.
Okay, so the engineers have to go back to the drawing board. They have to fix this lens cap problem.
They do. They spend the next few years tweaking the mechanism, trying to make it foolproof. They launch Venera 11 and 12 in 1978. These are improved landers. They've got color cameras this time. They also have a new instrument called GROZA to detect lightning.
And these probes were tough.
Incredibly tough. Venera 11 survived for 95 minutes. Venera 12 survived for 110 minutes. That's almost 2 hours on the surface.
Imagine the photos. Nearly 2 hours of high-resolution color data from Venus.
Imagine the soul-crushing frustration back in mission control.
Oh no, don't tell me.
On Venera 11, neither lens cap released.
You are kidding me.
And on Venera 12, neither lens cap released.
4 cameras, 0 pictures.
0. They sat there on the surface, fully functional, recording the temperature, the pressure, the wind, but they were completely blind.
What went wrong this time?
The prevailing theory is that the external atmospheric pressure, that 90 atmospheres, was actually physically pressing the caps down onto the lander with more force than the explosive bolts could generate to push them off. The atmosphere itself was holding the door shut.
That is just, it's tragic. I can't imagine being the engineer who designed that bolt, watching the data come back.
It wasn't a total loss, though. Remember that GROZA instrument?
The lightning detector.
While the probes were sitting there in the dark, they started picking up these low-frequency radio pulses. Static. It sounded like distant thunder.
Thunder. On Venus.
Yes. They confirmed that Venus has lightning storms, but without rain. Just massive electrical discharges ripping through the sulfuric acid clouds miles above, so you have to paint the picture. You are a robot, blinded by pressure, slowly cooking to death, and all you can hear is the thunder of an alien storm.
That's Gothic horror. That is straight out of a nightmare.
It really is. But the Soviets were nothing if not persistent. They were not going to let a stubborn piece of metal beat them.
Which brings us to Section 5, High-Res History and the Comedy of Errors.
Yes. Venera 13 and 14, 1982. This is the absolute peak of the program.
The masterworks.
They completely redesigned the lens cap release mechanism. They added color cameras, microphones, and a robotic drill to actually take soil samples.
So Venera 13 lands. Please tell me there's a triumph here.
Venera 13 is the champion. It landed on March 1st, 1982. It survived for 127 minutes. That is the all-time record. Over 2 hours.
And the lens caps?
They popped off, both of them, perfectly.
Finally.
And we got the first color photos of Venus. And the world is orange.
Why orange? Are the rocks orange?
Not necessarily. The atmosphere is so thick and dense that it filters out almost all the blue light from the sun. It's the same reason our sunsets on Earth are red, but on Venus, it's like that everywhere, all the time. Everything is bathed in this oppressive orange-yellow glow.
Wow.
So if you brought a white piece of paper, it would look orange. The rocks are probably a dark gray, the salt, but under the Venusian sky, they look orange.
And what about the audio?
The microphone worked. We have a recording. We can hear the sound of the wind on Venus. It's this low, crunchy, rumbling sound. And we also heard the sound of the probe's own drill operating.
The drill. I mean, that's an incredibly complex piece of machinery to run at 465 degrees Celsius.
It was. It drilled into the surface rock, it collected a small sample, and it brought it into a tiny airlock inside the probe to analyze it with X-ray fluorescence.
And what did it find?
It found something called lucite basalt. It's a rare, potassium-rich type of volcanic rock, which tells us that Venus has a very complex and different kind of volcanism than Earth. A huge discovery.
So Venera 13, total unqualified success.
An absolute triumph.
Yeah.
And then A few days later, Venera 14 lands.
I have been waiting for this story because this story, to me, sums up the entire human experience in space.
It really does. So Venera 14 was a twin of 13. It lands safely. All systems check out. The lens caps pop right off.
Great start.
Now, Venera 14 had another experiment on it. It was called the compressibility tester. Just picture a spring-loaded mechanical arm. Its job is to swing out, hammer the ground with a known force, and measure how much the soil gives way.
Simple physics. It tells you if you're on soft dust or hard rock.
Exactly. Swing arm, hit ground, measure the impact. So the arm swung out. It struck its target. But the data that came back was weird. It said the surface had perfectly rigid compressibility. It didn't yield at all, like it was made of diamond.
Why? What happened?
Because the arm didn't hit the ground.
What did it hit?
It hit the lens cap.
No.
Yes.
You have an entire planet, 460 million square kilometers of surface area to land on, and the ejected lens cap lands exactly where the hammer is going to fall.
Precisely. The lens cap popped off, tumbled down, and landed on the exact 4 square centimeter spot where the arm was pre-programmed to strike. The probe spent its entire 2-hour life on Venus, meticulously measuring the compressibility of its own lens cap.
That's statistical insanity. It's cosmic comedy.
It is the ultimate perfect example of Murphy's Law. But think about the irony. For a decade, the problem was the lens caps wouldn't come off. They finally fix it. The cap comes off perfectly, and it lands in the one spot in the universe where it can ruin another experiment.
If I was the engineer in Moscow watching that data stream in, I think I would have just gone home, just packed my bag and walked out.
Venus does not want us here, Ivan. Let's go have a drink.
Despite that unbelievable comedy of errors, do they get any other useful science from Venera 14?
They did, thankfully. The drill was on a different side, so it worked just fine. It found a different type of rock, tholeidic basalt, which is very similar to the rock that forms on Earth's mid-ocean ridges. So geologically, it was still a huge win, but history will always remember the lens cap.
It's a reminder that no matter how smart your engineers are, luck is always a factor.
Always.
So let's zoom out a bit. Section 6. Orbiters, balloons, and mapping. After this intense period of landers, the Soviets shifted their strategy.
They did. They realized that dropping these landers is fantastic for getting ground truth in one specific spot, but it's like trying to map the entire Earth by dropping one camera in a backyard in Kansas and another one in Siberia.
You don't get the big picture.
You don't get the global picture. And
Yeah.
they needed a map.
But the clouds are in the way. You can't use normal cameras from orbit.
So they used radar. Venera 15 and 16 launched in 1983. These were orbiters, and they carried synthetic aperture radar, or SAR.
Okay, explain SAR to me like I'm 5.
A normal radar dish, to get a sharp image, needs to be huge, miles wide, which you can't launch into space. SAR is a clever trick. As the spacecraft moves along in its orbit, it sends out little radar pulses. It then combines the reflections it gets back from all these different points along its path to digitally simulate a massive antenna.
So it builds a big antenna out of software and movement.
Exactly, and it allows you to get incredibly high-resolution images of the surface right through the clouds.
And what did they see? What did the first maps of Venus look like?
They saw a world of tortured geology, massive tectonic deformations, ridges, grooves, giant shield volcanoes, and they discovered these strange crown-like features they called coronae, which are formed by plumes of magma pushing up the crust from below and then collapsing.
So it confirmed Venus is geologically active.
Absolutely.
Right.
It's not a dead world, it's churning.
And finally, we have the Vega mission. This is 1984, kind of the end of the line.
Yeah, Vega is a great name. It's a portmanteau. Venera for Venus and Gale for Halley's Comet.
A 2-for-1 mission.
It was a brilliant plan. The mission was to swing by Venus, drop off some probes, and then use Venus's gravity to get a boost to fly on and intercept Halley's Comet, which was coming through the inner solar system.
And the Venus payload included something completely new. Balloons.
Yes. After all the crushing and melting, this sounds so peaceful, doesn't it?
It really does.
They dropped 2 balloons into the Venusian atmosphere, and they just floated.
At what altitude?
They stabilized at an altitude of about 54 kilometers. And this is the interesting part. At 54 kilometers up, Venus is actually kind of pleasant.
Pleasant.
Well, relatively. The
Yeah.
pressure is about half of Earth's sea level pressure, like being on a tall mountain. And the temperature is about 30 degrees Celsius, room temperature.
So you could survive there.
You could, in theory, float in a balloon there wearing a light jacket and an oxygen mask. The clouds are still sulfuric acid, so you wouldn't want to go for a swim, but it's the most Earth-like environment anywhere else in the solar system.
So the balloons just drifted around.
For 2 days. They traveled about a third of the way around the planet, pushed along by these super hurricane force winds. They gave us the first real map of the atmospheric circulation, showing how dynamic the weather is.
It's such a great contrast. The surface is hell, but the upper clouds are, well, acid, but at least a survivable pressure and temperature.
Exactly. It's a layered world.
We're nearing the end of our time, so let's move to our final section, summary and future. When we put all these pieces together, the crushed holes, the orange photos, the thunder, the radar maps, what do we actually know about Venus now, thanks to Venera?
We know its cautionary tale for planets. We know its surface is mostly basaltic rock, meaning it was probably resurfaced by massive volcanic eruptions in the geologically recent past.
We know it has no magnetic field.
Right, which means it has no protection from the solar wind, which has likely stripped away any water it once had. And we know the atmosphere super rotates. The winds move 60 times faster than the planet itself spins. It's a bizarre dynamic.
The big takeaway is the greenhouse effect.
That is the big one. Venus is proof of concept. It proves that an atmosphere can radically change the destiny of a planet. It trapped so much heat that its oceans boiled off, the water vapor was lost to space, and the rocks themselves started to glow.
So is anyone going back? Is Russia planning a return?
There is a plan. It's a mission in development called Venera D.
And the D stands for?
Dolazhushchaya. It's a bit of a mouthful. It means long-lasting.
How long is long-lasting on Venus?
The goal, the very ambitious goal, is to have a lander that can survive for 24 hours, maybe even longer.
That is a massive jump from 2 hours. How do you do that?
It requires completely new technology, new materials, new kinds of electronics that can actually run hot at 500 degrees without any cooling. Things like silicon carbide electronics.
And when is this supposed to happen?
The launch is tentatively planned for no earlier than the late 2020s, maybe the early 2030s. It keeps shifting.
It's an ambitious plan.
It is. And NASA has missions planned too. Da Vinci and Veritas. The European Space Agency has Envision. We are really about to enter a new decade of Venus exploration.
As we wrap up, I just want to reflect on the legacy of those Soviet engineers. We laughed about the lens cap, but honestly, what they accomplished was nothing short of miraculous.
It really was. You have to think about the conditions they were working in. They didn't have modern supercomputers to model the atmosphere. They were doing complex orbital mechanics with slide rules and punch cards.
And they were just throwing hardware at the most unforgiving environment we know.
And they kept going back. They would fail. They would analyze the failure. They would rebuild stronger, and they would try again. That persistence is incredible.
And to this day, they are the only ones. No American probe has ever sent back a picture from the surface. No European probe.
Only the Soviets. Those grainy, orange, 180-degree panoramas, they are the only eyewitness testimony we have from the surface of our sister planet.
It really makes you wonder, why? Why that obsession with this particular horrible place?
And that's really the question I think we can leave with. We know we can't live there. We know there are almost certainly no aliens there. It's a dead, sterile world. But we keep wanting to go back.
Maybe because it's a mirror. A dark mirror.
That's exactly it. Venus is Earth's evil twin. It's the same size, same mass, formed in the same cosmic neighborhood out of the same stuff. But one planet became a garden and one became a gas chamber.
And we desperately need to know why.
We need to know why to make sure we don't accidentally turn the knob on our own planet's thermostat in the wrong direction and end up like them. Exploring Venus isn't just about space exploration. It's about understanding the incredibly fragile balance that makes Earth possible.
On that cheerful note, don't boil the oceans, everyone.
Please don't.
That's it for this deep dive into the Venera program. A story of crushing pressure, melting lead, and the indomitable, sometimes comically unlucky human spirit to see what's under the clouds. Thanks for listening.
See you on the next deep dive.